The powerful risk Simtable function allows you to run a separate simulation for a list of values in some cell. This cell often corresponds to a decision variable, such as an order quantity, but it could contain an interest rate, a starting date for a project, a response rate to a new product, or any other quantity you would like to vary. In any such case, you supply a list of possible values you would like to try as arguments to a risk Simtable function. If the list is stored in a cell range, you reference this range. If you type the list manually, you need to include the list in curly brackets. Here are two possibilities. I'll reference a range. Or I will type the values inside curly brackets. Note that the first value is always shown. The model shown here, adapted from one of the at-risk example files, illustrates a possible use of the risk Simtable function. A company is introducing a new product, and the model estimates the NPV of cash flows from the product over a 10-year horizon. A key input to the model is whether a competitor enters the market at the beginning of year 1. This input is either 0 or 1, as shown in cell C8, and this is determined by the probability of entry in cell E8. The company would like to try 3 very different values, 0.1, 0.5, and 0.9, for this probability of entry to see their effect on NPV. To do this, you enter the risk Simtable function in cell E8 and specify its arguments as the list to the right. Again, it shows the first member of the list. Then you set the number of simulations to 3. Because you want at risk to run 3 separate simulations, one for each of these probabilities. If the number of iterations is set to 5,000, as it is here, at risk will run each of the 3 simulations for 5,000 iterations. Better yet, it will use the same random numbers for each of the simulations. This provides a fair comparison of the results for the 3 probabilities. By using the same random numbers, they all face the same scenarios. Now I will run the simulation. You can browse an output for any of the simulations. By default, you will see the results for the first simulation. But you can click the button with the pound sign to select any other simulation. Alternatively, if you'd like to use at-risk statistical functions such as risk mean, you can append a last argument, the simulation index, to any of them. In this case, the index is 1, 2, or 3. As you gain more experience with at-risk, you will probably see more and more uses for the risk Simtable function. For example, you might want to see how sensitive the distribution of some output is to the shape of some input distribution. The model shown here illustrates one such possibility. The demand in cell B15 drives the profit in cell F15, but the company isn't sure whether to use a triangular or normal demand distribution. With a risk Simtable function in cell B11, using the indexes 1 and 2, they can try both. The logic is then captured in the demand cell with an if function. If the index is 1, use risk triang. Otherwise, use risk normal. The results from running the 2 simulations are captured below with at-risk statistical functions, using last arguments 1 and 2. By now you should appreciate how useful the risk Simtable function can be. However, what happens when you enter it in 2 or more cells, each with its own list of possible values that you would like to try? You might expect this to run a separate simulation for each combination of values. For example, if there are 4 possible values for the first cell and 3 for the second, you might expect this to run 4 times 3 or 12 simulations. However, it turns out that this is not the behavior you will get. Fortunately, there are a couple of ways to get at-risk to run 12 simulations, 1 for each combination of values. The worksheet you see here illustrates these methods. You should first list the combinations of values you want to test, as in rows 4 and 5. In this case, each of 4 mean values will be paired with each of 3 standard deviation values. So you set the number of simulations to 12. In general, this table of combinations can have any number of rows, 1 per variable, and any number of columns, 1 per combination of values. The model itself doesn't do much. The input and output are each a normally distributed random value with mean and standard deviation equal to one of the combinations. At-risk statistical functions are used in rows 19 and 20 to verify that risk Simtable is working properly. In the first method, you enter a separate risk Simtable function for each variable in cells C8 and C9 with argument equal to the entire corresponding row of the table. The means, and I can copy that down for the standard deviations. It would be tempting to list each possible mean only once and each possible standard deviation only once, as indicated in the red cells. However, this would be incorrect. It would not give you the results you would expect. In general, if you set the number of simulations to a number such as 12, then when at-risk runs simulation number 4, say, it uses the 4th value in each risk Simtable function it finds. If a risk Simtable function has fewer than 12 values, the corresponding simulations return errors. For example, if you have a risk Simtable function with a list of only 10 values, and you set the number of simulations to 12, the 11th and 12th simulations will return errors. On the other hand, if you have a risk Simtable function with a list of 14 values, and you set the number of simulations to 12, the 13th and 14th values will be ignored. They will never be used. In the current model, the risk Simtable functions in cells C8 and C9 each have lists of length 12. So it is correct to set the number of simulations to 12. Now I will run the simulation. As you can see from the results below in rows 19 and 20, everything is working as it should. The means and standard deviations match up to the values up here. An alternative method you might prefer is to use a single risk Simtable function with a simulation index going from 1 to 12. Then you use lookups to find the appropriate parameters. For example, in the version shown here, I will enter a risk Simtable function in cell J7 using the indexes 1 to 12. I'll highlight the indexes. As usual, it shows the first value. And then I will capture the appropriate mean and standard deviation in cells C8 and C9 with HLOOKUP functions. Looks up the index in this table and finds it in the second row. For the standard deviation, it will find it in the third row. Now I will run the simulation again. As you can see, you get the same basic results as before. You might prefer this lookup version, but it does take more computing time, which could be an issue on more complex simulation models. The reason is that it is looking up values frequently in the lookup tables.